In chapter 2, we work with equations. This is like the major equations chapter. Solving one-step equations is section 1. You've all seen it before, hopefully. If not, this is a quick review or like a quick crash course in how to solve one-step equations. We're going to be using the addition property of equality in this section and the subtraction property of equality. What these mean is you can add, if you have an equation, you can add the same number to both sides of the equation and you will still have a true equation. So that's what this says right here. You can add the same number to both sides of an equation and it will still be true. For example, if A equals B, so these are just two numbers and they equal each other. If I add C to both sides of this equation, I get a true statement. Okay? So for example, if I had 4 equals 4, and then I decide to add 3 to both sides, I would have 4 plus 3 equals 4 plus 3. And we get 7 equals 7. It's still a true statement. Okay? If I had x equals 6, then I could add 3 to both sides, let's say, and get x plus 3 equals what? 9. And that is a true statement. Because x equals 6, x plus 3 equals 9. Okay, that's the idea behind the addition property of equality. The subtraction property of equality is the same kind of thing. It's just that we're subtracting now. You can subtract the same number from both sides of an equation. So if I have a over b, a equals b over here, and then I subtract some number c from a, and I subtract the same number c from b, I will wind up with a true statement. So if I have something like x equals 6 again, and this time I subtract 4 from both sides, then what I get is x minus 4 here equals 6 minus 4 here, which is 2. So I get x minus 4 equals 2. Okay? What we're going to be doing is we're going to be given equations that look like this and equations that look like this, and we're going to get rid of this plus 3 here, so it's just x equals. That's the whole idea behind solving equations. You just solve for x, get x by itself, or whatever the variable happens to be. So we can solve equations by using the properties of equality as long as we keep the equation in balance. What we do to one side, we have to do to the other. And that's what I mean by this means. What we do to one side must be done to the other side. And that keeps the equation in balance. Think of a scale. If you put something on one side of a scale, the scale's out of balance. So you have to put the same something on the other side of the scale to keep that scale back in balance. The same thing is going to happen here. So right now, what I want you guys to do is, as you're doing these problems, see the x plus 13 equals 27, but realize that we're doing something to x right now. What are we doing to x right here? We are adding 13, right? I don't want to add 13 to x anymore. I just want it to be x. So to undo, add 13 to x, you have to subtract 13, okay? So to get this 13 to disappear, I'm going to subtract 13. But if I subtract 13 to one side, I have to subtract 13 from the other side as well to keep the equation in balance. And that would be the subtraction property of equality. Why is it the subtraction property of equality that we're using? It's really a very simple answer. Because we're subtracting, yeah. You're using the subtraction property of equality. So we get x. The 13 minus 13 becomes 0. It's gone, okay? The equal sign comes down. And then we have 27 minus 13, which is 14. We get x equals 14. X is now all by itself, so that's my answer. Did you get it? On the second one, we have y plus 2 equals negative 6. If I want to get y by itself, then what do I need to do? Subtract 2. This thing needs to disappear so that y is by itself. So I'm going to subtract 2. But what I do to one side, I also have to do to the other. So I'm going to subtract 2 here as well. The y comes down. 2 minus 2 is 0. It's gone. The equal sign comes down. And then I have negative 6 minus 2, which is negative 8. So that's my answer. And on the last one, we have 15 plus s equals 42. I want s to be by itself. What am I doing to s right now? I'm adding 15. So how do I take care of that? I'm going to subtract 15. But what I do to one side, I have to do the other. So I'm going to write minus 15 on the right side as well. The 15 minus 15 is gone. I'm left with just s equals 42 minus 15 is 27. So that's the answer. Okay? All three of these were using the subtraction property of equality. I know it's the subtraction property of equality because on all three of these I subtracted something from both sides. The next three will use the addition property of equality. To get b by itself here, I'm currently subtracting 3 from b. So what do I have to do to get rid of that minus 3? Add 3. We're trying to get that to turn into 0. So I'm going to add 3 to both sides. On the left side, I have negative 7 plus 3, which is, it's negative 4. The equal sign comes down. I didn't do anything to the b, so it comes down. And negative 3 plus 3 is 0. So it's gone. I have just b on the right equals negative 4 on the left, and I can leave my answer just like that. We've talked about that before, right? You can leave your answer like that. If you want to, you can flip it, but this is perfectly fine here as well. So if you flip it, it's just one more thing that you got to do. Okay, what should I do on the next one? Yep, we have m minus 8. So to undo that minus 8, we got to add 8. So I'll write plus 8, and I'm also going to write plus 8 on the other side. And I get m, negative 8 plus 8 is gone, so then the equal sign comes down, and this is negative 6. Do not lose your negative signs. Pay attention to those. If this was your homework and you gave me 6 instead of negative 6, it's just wrong. If this was a test and you gave me 6 instead of negative 6, you're losing a point, 1% of your test, just by losing the negative sign. Pay attention to those. All right, finally on this last one, what do I do? Add. So that would be called 3 halves, right? We have y minus 3 halves here. To undo the minus 3 halves, I'm going to add 3 halves. So plus 3 halves to both sides. Okay. What is 1 half plus 3 halves? It's 4 halves. I can actually add these because we have common denominators. So then I add the numerators and I get 4 halves. The equal sign comes down. I didn't do anything to the y, so it comes down. The negative 3 halves plus 3 halves goes away. We always reduce our fractions. Does this fraction reduce? Yeah, what does it become? 2. 2 over 1, which is just 2. So I'm going to reduce that to 2 equals y, and that's my answer. We have addition and subtraction properties of equality. We also have multiplication and division properties of equality, and they basically are doing the same thing. You can multiply the same number to both sides of an equation for the multiplication property of equality. For the division property of equality, you can divide by the same number on both sides of the equation. So for example, in algebra, we would say if a equals b, then if I multiply this number c to both sides of the equation, I wind up with a true statement still. So my example, if I have x equals 4, then I can multiply both sides times some number, the same number, and I still get a true statement. This would simplify down to 3x equals 12. Same statement. For the division property of equality, if I have a equals b again, just like on all the other properties of equality. But now I divide A by some number, and I divide B by that same number, I wind up with a true statement. So for example, if I have x equals 12, let's say 3x equals 12 actually, and I divide both sides by the same number, so in this case 3, I wind up with a true statement. 3x divided by 3 is x equals 12 divided by 3, which is 4. How do I know I'm using the division property of equality if I'm looking at it? Because I divided. Okay? Very simple. So to solve any equation, you're trying to isolate the variable. The word isolate means get it by itself. That's one of your vocab words. That means get the variable by itself. You do this by using what we call inverse operations. All inverse operations do is undo what's being done. So for example, subtraction undoes addition. Division undoes multiplication. Multiplication undoes division. Okay? Those are all inverse operations of each other. So just keep those in mind. Squaring undoes square rooting, just in case you were curious. Okay, we're going to solve these 9 here, and we're going to keep the equation balanced as we go. That means what we do to one side, we have to do to the other. What is being done to x right here? We're multiplying by 4. So how do I undo multiply by 4? Divide by 4. So I'm going to divide this side by 4 and this side by 4. Well, 4 divided by 4 is 1. So I'm left with 1x, or just x, equals 64 divided by 4, which is, you're getting there, 16, isn't it? I think it's 16. So x equals 16 is the answer. Okay, let me do, let's see, the one next to it. What is being done to x? Multiplying by 15. So to undo that, we are going to divide both sides by 15. 15 divided by 15 on the right side is 1. So I get 1x. And then 10 divided by 15 is 10/15. It's just a fraction. It's a division problem that we can't do. So that means if I have a fraction, what do I have to do? Reduce it. 10/15 reduces down to 2/3. Always reduce your fractions. Just like always check for negative signs that you may have lost along the way. Let's do the next one. Negative 3.2z equals 14. What do I do to get z by itself? Good. Divide by negative 3.2 to both sides. On the left, I get z. 1z equals, on the right, 14 divided by negative 3.2. I have no idea. How could we figure that out? The answer is not just sit there and wait. How could we figure this out? Use a calculator. So someone with a calculator, type that in. 14 divided by negative 3.2. What do you get? I know that's wrong. What do you get? Nope. Negative 4.4. I think you guys think I'm joking about this negative sign thing, but every time I ask you to tell me something, you don't give me the negative sign. You have to pay attention to those. I am not joking. Next, 2x equals 3/5. What do I do to get x by itself? Divide by 2, yeah. Divide both sides by 2. So now I have what on the left? x equals, how in the world do I deal with 3/5 divided by 2? Okay, so that's 3/5 divided by 2 over 1. And how do I handle that giant composite fraction? What was that? So you're saying leave it, change it, flip it, right? So this becomes 3/5 times what? 1 over 2, which is 3/10. Good. X equals 3/10 is the answer. Didn't need a calculator for that, but I did have to think a little bit more than usual, which is fine. All right, the middle square now, if we're playing tic-tac-toe. What are we doing to x here? We're dividing by... We're dividing by 4 here, so that means to undo divide by 4, we are going to multiply by 4. That's right. So I multiply by 4, and that's how I'm going to write that. I got to keep the equation in balance, so I'm going to do the same thing to both sides. On the left side, what do I wind up with? X. On the right side, what do I wind up with? Thank you, negative 36. That's my answer. What do I do on the next one? Multiply both sides by 3 to get rid of the I got to undo that division by 3. So on the right side, I wind up with r equals what? 57. Next line down, what am I doing? Multiply both sides by negative 9 because I am dividing x by negative 9 here. I got to undo that by multiplying both sides by negative 9. And notice how I write this multiplication going on the right-hand side. I'm using parentheses so that I don't accidentally subtract. I want to multiply. On the left, I get what? X equals. On the right, what do I get? Good. Negative 72. Okay, next one. What do we do? Multiply both sides by 5. And on the left, what do we get? On the left, x. On the right, we get negative 60. And finally, what am I doing to x? I'm multiplying it by 1/3. What can I do to undo that? I could divide by what I'm multiplying by, which would be 1/3. I could multiply by 3 over 1. What's 1/3 times 3? It's 1, right? 1/3 times 3 reduces down to 1, which would just give me 1x, which is just x. So how about I just multiply both sides by 3? 3 times 1/3 is 1, so I'm left with x equals 24. That's a little bit easier than dividing both sides by 1/3. You would get the same answer by doing leave it, change it, flip it. But this is a little bit easier. So that last problem with the 1/3 on it was easier to solve by multiplying by 3 than dividing by 1/3. If we want the coefficient means the number in front of the variable. So the coefficient in front of the variable, we want that to be 1. How can we turn the coefficient on the variable below into a 1 in one move? So I'm talking about that 4/5 m. How can I turn 4/5 m into just 1 m in one move? Multiply by the reciprocal. Yep. So you're going to say multiply by reciprocal. The reciprocal of 4/5 is 5/4. So I'm going to multiply both sides here by 5/4. Now here, 4/5 times 5/4 becomes 20 over 20, which is 1. And I'm just left with m equals. Now over here, I do have a little bit tougher work to do. 28 times 5 divided by 4 is basically what that says. or you could do 28 divided by 4 first and then times 5. I think 28 divided by 4 is easier. That's 7. 7 times 5 is 35. So there's your answer. So on this one right here, I'm going to multiply both sides by 4/3. On this one, I'm going to multiply both sides by 3/2. And on the last one, I'm going to multiply both sides by 2/5. And that's how you do those problems. Of course, now we want to simplify them down. We get x over here equals 16 on this one. We get n here equals 18 on this one. And we get x here equals 6 on the last one.